All right, welcome back to Mr. Powers Teaches Algebra or Trig. So anyway, we like to teach trig and algebra a little bit, and so we do this in geometry. And so if you watched the video I just did on angles, I think that might be a little helpful for when we start looking at this, and that is to realize the the angles start repeating themselves, kind of. And we're going to get there where, okay, like 22 degrees and then 22 plus 360 on that unit on the Cartesian plane there, when we're swinging around the origin, ends up in the same spot. If we were to somehow, we haven't done it yet, create a way to find these function values on those angles that we swinging that angle around on the Cartesian plane or on the origin, then these probably would give the same values. A sine of 22 would be the same as sine of 360 plus 22. It would be 382 degrees, that is. They should give us the same values because those rays are kind of in the same spot, right? And so that's kind of a neat thing we can connect there. And that is actually what happens. But for now, we're not quite there yet. For now, we're just going to look at right triangle trigonometry. So we're just going to look at angles inside of right triangles, and we're going to extend that out later so we can get more angles. We can plug in more values for sine. So for now, let's just pretend like an angle can be anywhere from 0 degrees to about 90, maybe right under 90. We'll play around with that and see what we think. Okay, so this is very important. Whenever we have a right triangle, we're going to label an angle. For now, for this guy, we have T. And then the angle, and then we have different sides we label. Okay, here we have a right angle. There's always a right angle here. Oh, hold on one second. So right here, wherever we have a right angle, where we get this L shape, we always have one of those in a right triangle. Right across from it, and you kind of connect those corners up, we have that side, and that side is always a hypotenuse. And we say that the hypotenuse is opposite the right angle. Okay? Opposite the right angle. And that's very, very important to know. It's always opposite the right angle, the hypotenuse. And then opposite our angle that we chose, so in this case T, opposite of that. So again, we got these two rays here that are making T right here. Okay? We go opposite of that. So go out from the corner and make sure we don't touch any of those sides. We keep going. We get the opposite side of that angle. Okay, it's all in respect to the angle we're talking about, except for hypotenuse. Hypotenuse always stays the same. But the opposite side, that's how we find the opposite side of T. So this being the opposite, we would say that's opposite of T. So opposite of angle T. And then adjacent is going to be the other side, or as some people like to say, adjacent means next to. In whatever context you're using it, be it English or math, it is always next to. That's what adjacent means. So, of course, there's two sides that are adjacent to angle T here, but one of them is going to be the hypotenuse. So it's not going to be that one. The other will be our adjacent, right? Because that means next to. So then we have our adjacent side of T. Okay? And it's very, very important to be able to label these sides if we have an angle. Because let's say we had an angle theta here. The hypotenuse is still the hypotenuse, but now the opposite of theta is over here. They got switched. The opposite side and adjacent side are switched. So like I said before, these are respective to the angle we're talking about. It's very, very important. So when I say sine of t, it's going to be whatever, if we're given a right triangle, it's going to be whatever value the opposite side is over the adjacent. So, for example, I can do a really easy example right now, and we can get sine, cosine, and tangent of t right now. And so we can do that. And we don't need to know what the angles are. And this triangle is not to scale. I'll tell you right now. Actually, I can do a better one. Whoops. Okay. All right. So here we have a triangle. And let's go ahead and we'll call this angle T. I could do it up here. It doesn't matter. But if this is T, go away from it. This is my opposite. And I'll label it as such, OPP. And then the opposite of my right angle is a hypotenuse. There's my hypotenuse. And then the other side must be my adjacent side. That's how you do it. And you need to be able to do that reliably every time. And then we can easily find what these are. So now in this case, I'm going to go ahead. I'm going to have lengths for each side. Let's say this side is 3. Okay. The adjacent side is 3. This length here is 4. And this length here is 5. And I know that those are lengths of a right triangle. And you can check that with a Pythagorean theorem, but we're not going to do that right now. These can be actual sides of a right triangle. And so I can find, I don't know what angle T is. We can use a calculator and inverse trig functions, inverse sine or whatever, to figure out what this angle is. But we don't care about that right now. We know there's an angle here. We don't care what it is. Judging from this picture, I can say what the sine of the angle is. Because right here we have sine is opposite over hypotenuse. So we'll go sine of t is opposite. And we don't say sin. We say sine, cosine, tangent. That's how we say it. We don't say sin, cos, tan. No. Okay. Sine of t equals opposite over hypotenuse. Very important to memorize these. Or at least have them handy to look up. But they're easy to memorize. So opposite over hypotenuse, so that's going to be 4 over 5. And that's it. I got my sine. Sine of t is 4 over 5. It's easy. It's a ratio. I can change it to a decimal if I want, but I don't feel like it. All right, so then cosine of t, just as easy. That's going to be adjacent over hypotenuse. And so adjacent is my 3, because I labeled this already, so it's super easy. Hypotenuse is still 5. And then tangent is defined as opposite over adjacent, and we can make this relationship too, and I'll leave it to you. Tangent of t, it says opposite over adjacent. Play around with it. I'm going to leave this as an exercise for you. Play around with that and see if you can actually define it as sine of t over cosine of t. Does that give you opposite over adjacent? Play around with that. See if that's true. So tangent of t, opposite over adjacent. So the opposite is 4, and the adjacent is 3. There, I got all my ratios done. And so that's our right triangle trig. Sine, cosine, tangent. Easy stuff. All right, so thank you for watching, and until next time, enjoy doing math.